Lesson 6.3, solving compound inequalities. So yesterday we talked about solving inequalities, and we had something like 2x is greater than 12. So we would divide by 2, and x is greater than 6. So we knew, all right, we graph it, we draw an open circle because with the greater than sign we have an open circle. Now if it was greater than or equal to, we would have had a closed circle, and then we just draw an arrow towards the numbers that are greater than 6. So what we're going to be dealing with today is the same type of problems. We've still got inequalities, but they are compound inequalities. When I have a compound inequality, you will look at this problem, and how many inequality signs do you see? Zachary? 2. Where is your variable in relation to those inequality signs? It's in between them. They're in the middle of the inequality signs. See, here are my inequality signs. Less than or equal to, less than or equal to. And my x is right here in the middle. I need that variable to always stay in between the two inequality signs. When I get to my final answer, I should still have 2 inequality signs, and my variable should still be in between those. Here's the biggest mistake people make when they're doing this problem is they say, oh, okay, well, I'll just add 2, and then that goes away, and I'm left with 3x minus 6 is less than or equal to 10. Easy. No. In all my years of teaching, that's the mistake that everybody makes on these problems. Well, not everybody, okay? So what we've got to do is I've got to say, okay, I need my x to stay in the middle. So I need to start moving things from the middle to the outsides because I want the x to stay in the middle. So if I'm trying to solve for x here, what would you do first, William? Add 8. What happens is that 8 cancels out in the middle, and I have to add it to both the front and the back. So I put plus 8 here and plus 8 here. You put it on either side of the inequality. So negative 2 plus 8 is 6, is less than or equal to 3x, is less than or equal to 18. Now I'm still trying to get x by itself, so Courtney, what would I do? I don't want to add 6 because, very good, divide by 3 because I'm just trying to get x by itself. So it cancels out here. So I divide by 3 on both the front and the back. So what's 6 divided by 3? 2 is less than or equal to x is less than or equal to 6. 18 divided by 3 is 6. Here's the thing about compound inequalities. What they tell me is that I have a 2 and a 6, and x has to fall between those two numbers. So when I graph it, okay, I'm going to have a 2, 3, 4, 5, 6, and I'm going to graph this on the same number line. So my circle that goes over my 2, is it going to be open or closed? Closed. My circle that goes over my 6, is it going to be open or closed? Closed. And since this is a compound, I know x can be any number between them. So I can shade every number between. So you can either draw a line that connects them, or you can shade the number line. Either way, as long as we know that x is going to fall between 2 and 6. Make sure you remember, whenever we have compound inequalities, we will always connect the dots. That's the easiest way for me to put it. Your shading will always be between the two dots, or you're always going to connect them with a line. It'll never be anything different. If you ever get anything different, it is wrong. Okay, so let's do the next one. What would I do to get x by itself? Sarah, what should I do first?
You're going to subtract 3 on the side.
Very good. Subtract 3. And I subtract 3 everywhere. So negative 5 minus 3 is what? Negative 8 is less than or equal to 2x is less than 4. Then what would I do? Divide everything by 2. Negative 8 divided by 2 is negative 4. Less than or equal to x. Less than 4 divided by 2 is 2. Again, I've got to graph this on the same number line. So I say -4, -3, -2, -1, 0, 1. I'm going to make this a little bit longer. And 2. What kind of circle am I going to have over -4? Zachary?
Shaded, yeah.
Shaded circle or a closed circle. What type of circle am I going to have over 2?
Open.
Open. And what am I going to do?
You're going to connect the dots.
Connect the dots. Very good. Okay, so next example. Remember that one rule that we learned yesterday about these. If I multiply or divide by a negative number, what do I do to my inequality? Change it or flip it. If it's less than, I make it greater than. If it's greater than, I make it less than. So keep that in mind when we do this problem. We're still just trying to get x by itself. Valentina, what would I do first?
You add 2 on both sides everywhere.
Very good. Now here's my question to you. Because I added 2 in the middle, it canceled out. But look at the first or the front of my inequality. -2 plus 2. What's -2 plus 2? 0. Is 0 a place on the number line? Yes. So I want to leave my 0 right here because it's an actual place. I can't just say, oh, they cancel out so they go away. No, it's actually a 0. You say, well, wait a second. What about the one in the middle? It's the same thing. Right, well, we're moving that +2 out, and yeah, technically it does equal 0, but I don't need to put it because I'm trying to make everything go away in the middle. Okay, so 0 is less than -x is less than 3. Now, what is the number in front of x? Cole? -1. So what am I going to do to get x by itself? Divide everything by -1. There should be a siren going off in your head because we've divided by a negative number. And what does that mean I have to do? Switch my signs. 0 divided by -1 is still 0, but now it is greater than. X is greater than 3 divided by -1 is -3. Now here's the thing you got to watch out for. Because now my problem is flipped around. Which one of these numbers is smaller, 0 or -3? -3. So on my number line, I need to make sure and start it from smallest to biggest. So I have to start with -3 and end at 0. What type of circle am I going to have over -3? Open. What type of circle am I going to have over 0? Open. And we still connect the dots because it's still an and inequality. Next problem, Blaine, what would I do first? Very good. Add 1 to both sides, or everywhere. -3 plus 1 is -2, less than -2x, less than or equal to 6. What would I do now? Divide by -2 everywhere. Again, you should have sirens going off in your head because what did I just divide by? A negative. -2 divided by -2 is +1. And then instead of less than, it's going to be greater than. X greater than or equal to 6 divided by -2 is -3. So I draw my graph. Which one of these is my smaller number? -3. So I need to start with -3. So what type of circle am I going to have over -3? Closed. What type of circle do I have over 1? Open, and I just connect my dots. Now, there's one other type of compound inequality, and they are called OR problems. So the ones that we just did were called AND problems because basically 2 is between this number and this number. But OR inequality says, okay, x is going to be smaller than this number and greater than this number. It's always going to be going in opposite directions. So and always comes together, or always goes opposite, okay? When we have OR problems, we are going to treat these as 2 separate problems because they are, but we're going to graph their answers on the same number line. So let's start with just 3x plus 1 is less than 4. This is a good review from yesterday. So Stephanie, what should I do first? Very good. Subtract 1 everywhere. 3x is less than 3. Then I divide by 3. And x, actually I'm going to write it over here. X is less than 1. So there is one of my answers right here. I'm going to box it in because I know that's one of my answers. But now I need to do the other part of the problem. So I say 2x minus 5 is greater than 7. So what would I do first? Add 5. 2x is greater than 12. Then I divide by 2. And x is greater than 6. So look at these two inequalities because they have to go on the same number line. So I know x is going to be less than 6. So it's going to be towards the 0, negatives, whatever numbers. And then x is greater than 6. So x is going to be bigger than 6. So it's going to go 6, 7 towards those numbers. So they're going in opposite directions. But I want to graph it on the same number line. So when we're doing OR problems, I like to do one number larger than the two numbers I've found. So I'm going to, one number larger, one number smaller. So I'm going to say 0, 1, 2, 3, 4, 5, 6, 7. What type of circle am I going to draw over the 1? Open. And its x is less than. So it's got to go in this direction because it's all the numbers smaller than 1. Then 6. What type of circle am I going to draw over 6? Open. And its x is greater than 6. So it's going to go in this direction because it's every number larger than 6. So does everybody see how OR inequalities will always go in opposite directions? They will never go in the same direction. They'll never meet in the middle. They will always, always, always go opposite. And if you do have them meet in the middle or you do have them graphing the same way, you've done something wrong. Okay? Next problem. Same exact thing. Valentina, what should I do first?
You add 5 on both sides.
Very good. Add 5. Jarrett, once I add 5, what do I get?
6x is less than 12.
Very good. Caitlin, what am I going to do now?
Divide by 6.
Divide by 6. And Mackenzie, x is less than what? 2. Brianna, next problem, what am I going to do? Subtract 1. Very good. Then I have 8x is greater than 24. Vincent, what do I do now? Divide by 8. And Nishan, what is x greater than? Three. Very good. So now I need to draw my number line because I know x has got to be smaller than 2 and greater than 3. So I'm going to do 1, 2, 3, and 4 on my number line. What type of circle am I going to have over 2? Open. And I go towards the smaller numbers. What type of circle am I going to have over 3? Open. And I'm going to go towards the larger numbers. So opposite directions. Here is tonight's homework. And number 10 is your exit ticket. Just do them in order because we will have time to check them before you leave class. So go ahead and start working on tonight's homework.